Hello everyone and welcome to this video. In this video, we're going to be taking a look at how to identify and exploit an SSRF vulnerability through the use of a practical lab here on the INE platform. So this is going to be quite a complex lab, and we're going to be going beyond the standard just identify and exploit a vulnerability, but we're also going to take a look at how to chain vulnerabilities. So SSRF is just going to be one aspect or one part of the overall exploitation, but hopefully this gives you a complete view, not just of how you can leverage or how you can exploit SSRF vulnerabilities, but also get an understanding as to the different forms an SSRF vulnerability can present itself, or where they can be found, but also how to combine one exploit or one vulnerability in order to take advantage of another, or vice versa. But to cut things short, as the title suggests, we're going to be exploiting an SSRF vulnerability to achieve our objective, which in this case is remote code execution. So as I mentioned, this video has a lab associated with it. It's quite lengthy. The lab has all the documentation, or pretty much a walkthrough of everything that I'm going to be going through right now. I would also like to point out that this lab will provide you with access to a pre-configured Kali Linux system, so you don't need to use your own. But I'm not going to take any more of your time. I'm going to fire up my lab, and I'll see you within the lab environment. All right, so I am back within the lab environment, and as you can see, you'll have access to a pre-configured Kali Linux system. The first thing you want to do is just open up your browser, and we're just going to check if the target web application is running. Now, the host name of the target is demo.ini.local, as it is documented in the lab documentation. So it's probably a smart thing if we are to, just ping demo.ini.local and see what the IP is. The reason this is important is because in your case, or in your lab, the IP will be different. So demo.ini.local, there we are. So we get it. This is the IP in my lab. So just keep that in mind. And we're now going to perform a quick nmap scan. We'll perform a SYN scan, service version detection scan on the default 1000 ports that nmap scans, or, within the default port profile, if you will, or just 1000 of the most commonly used ports, I should say. But there we are. That's done. And right over here we can see we have quite a lengthy service banner here, but we have SSH running Ubuntu, or running on Ubuntu, so we know that. We have what appears to be a web server running on port 5000, as well as another HTTP web server, Python based. So most likely we're dealing with a Python based web application, or web server, or I should say application server for that matter. So 5000 and 8000. So let's try and access demo.ini.local now. .local on port 5000. And right over here, you can see sort of our input, or our first attack vector, which is an XML validator. So based on what we had covered, in the advanced injection attacks course, which, essentially involved XML-based attacks, we talked about standard XML injection, but also XML external entities, and we're going to be leveraging or exploiting that first before we get into SSRF. So the bottom line is we have an XML validator. So what's the next step? Well, the next step obviously is to create some sample XML, because this validates XML, right? And let's see what the output is. So I'm going to create a simple XML file, or just some XML code that we can test out. Very, very simple, and we can then try and see what output we get. All right, so I've created a very, very small snippet here. You can see it has the correct formatting, so XML version, encoding, and then we just have just called the parent, because if you remember in the other course when we're talking about XML and how it differentiates itself from HTML, one of those things was the fact that there's no predefined tags. So we have a parent, we just need to follow a format. So parent, child, and then very basic. So this is formatted correctly, of course. So let's paste this in here and let's see what this tells us. Aha, excellent. So it says the supplied XML is valid. And then it looks like it pretty much just displays it or reflects it back on the screen. Or I should say reflected in the response, but it's not rendered. It just displays exactly what we put in, but not formatted, obviously, because its job is just to validate it, right? So what if we take advantage of an XML entity, you know, or at least test and see if that works? Well, what we can do is, if you remember, we'll just go to our previous snippet here. So XML, and then in here where we define our entities, we're just going to say doc type, and we are going to say replace, and we then specify our entity. So the format should be simple, like so. We're just going to say entity, like so, and then description, we're just going to say, you know, test entity or something like this. And then we are going to close the angle brackets and then close this and angle brackets again. So this should suffice. What we're essentially testing for is whether, you know, this parser is vulnerable to XXE or XML external entities. Not really external at this point, but, you know, we can test it out. So I'm just going to paste this in here, validate that, and you can see it tells us it's valid, which is interesting. And what we're looking for is the description. So test entity right over here. You can see that that is specified in the response, you know, in the XML entity. So that pretty much confirms that this parser has an XXE vulnerability. So what can we do with this? Well, we can, you know, try and reach out to or leverage an external entity, if you will, or we can try and access the contents of, you know, a specific file on the underlying system. So for example, we can try and access the, the procnet TCP file, which will essentially display on Linux. It essentially on Linux systems, this file contains information on the current TCP network connections. So let's go ahead and modify this. And now instead of saying, file, so entity, we can create a new one here. And I'm just going to create a new one. All right, so there we are. In this case, I've gotten rid of, some of the rest, I've gotten rid of the other tags here. So just keeping it simple. So we still have doc type data, but now the entity is file system. And then we're utilizing the file operator here to get procnet TCP. So this should give us some IP addresses. They may be encoded, although we can probably take a look at how to decode this stuff. So validate. There we go. We can see it's valid. And yeah, this looks like we can see the data tag here and then local address. And then, yeah, these appear to be base 64 encoded. So we can pretty much at this point try and decode these, and we can actually utilize we can try and utilize a script to do this for us. We probably want to convert into the hex to, convert it from hex to, let's say, dotted decimal notation. So I'm going to use a Python script to do this for me. So let me just go ahead and create that here. This should also be outlined in the lab documentation. All right, there we are. So this is it. It's fairly simple. We have our imports here. So we're importing socket and struct. Hex IP is equal to, we'll need to provide the, the actual IP in hex format, and then address long is equal to int hex IP 16 right over here. So I'm going to save this now on my desktop here to convert .py. All right, there we go. And we can open up our terminal. Let me go ahead and navigate to my desktop, and we're going to say python 3 convert.py, and we see we need to supply an IP address in hex, so we can copy one of these IPs here in hex. Let me just find one. That doesn't look like hex there. What about this one right over here? So I'll go ahead and supply this in here, and we hit enter, and you can see there we are. So that's localhost 127.0.0.1. Okay, not really interesting, but this is an example of what you can do, you know, or what you can get as a result of successfully exploiting an XXE vulnerability. So let's try and find the other one here. These all seem to be empty. What about this one? Let's see. We probably want to try as many as we can. No, that's not what we're looking for. We have this value here. Let's try this. Let's see what we have in here. So Python, put that in here. 192.24.23. Is this my IP address, or is that the IP address of the target web server? 24.23. Yes, it looks like. Okay, so that's that value. And let's see. So if I go back in here, that if that's localhost, then that means no. Let's see if I go in here. What about this one? Okay. I'm just trying to find one specifically here. What about this one? Let's go ahead and try this one out here. All right, so 127.0.0.11. Anyway, this is not really that important. Just wanted to show you how you can, again, take advantage of the XXE vulnerability, how to dump, you know, a specific file or the contents of a file, how to make sense of it, because, you know, formatting is quite important. From this point now, we can also, you know, we can probably also try and convert the ports, which, you know, I think is quite important. So obviously, based on the format here, we can see that after every IP, we have the port separated by colon. So this is hex here. So we can actually use Python just natively to convert that. So, you know, we're going to say Python 3. And I think we can just say, you know, 0x, obviously in the correct format. Hit enter. That's port 8888. Interesting. Okay, that's also running. Very, very strange. Let's go ahead and check some of these other ports out. Let's see right over here. What about this one? Okay, 0x, try that out. 22, so that's SSH. This is localhost. Let's try and find another one here. Let's see, 000. Okay, this one might be interesting. Actually, wait, hold on a second. That's the TCP port range there, I can see. I have this one here, quite interesting. But if we go back up, there probably should be others like port 5000, 8000, etc., which we've probably missed. But this is on a, you know, different system that we may not have access to these ports in any case. So this is, you know, sort of the internals now of the web application or the application server, and you know, some of the other components that it can access. So we can go ahead. I'll just try one more like this one here. 35871. Okay, interesting. Yeah, so we can, you know, you can pretty much enumerate this info. Again, this is not really the focus, but one of the things you might have realized is that there is an SSRF vulnerability that, you know, essentially is inherent to the XML parser, and the fact that, you know, we can call for, or we can use, you know, I would say in this case, external entity. And well, how do we take advantage of it? Well, what we can do is we can, let's say, create a DTD file, and you know, I explain what that is, and then utilize the XML validator to see whether it actually, you know, fetches or reaches out to the address of the external entity, which, you know, will essentially be a web server that we are hosting. That web server will contain the DTD file because, again, external entity needs to point to something. Usually it's a DTD file. Now, in case you've forgotten a DTD file, DTD stands for document type definition, and what it does is it just defines the structure and the legal elements and attributes of an XML document. And pretty much, in terms of why it's used, is it's typically used by web applications to verify XML data is valid. So we can essentially utilize the XML external entity to fetch a DTD that then defines what we can actually do in or via XML, if that makes sense. So from this point on, what we could do is, let's go ahead and we probably want to create a DTD file. So let's start there. I'm just going to create a simple one here. I'm just going to create a new file. Okay, and there we are. I've just created a quick DTD file. As I said, this is something already explained in another course. But what this will do, as you can see right over here, file contents, all, entity all, and then entity file content start, etc. It will essentially allow us to read specific files from the file system. And in this case, the file system is localhost port 8888. Right over here. That was the open port we found, and we're going to want to save this, and I'm just going to save it on my desktop here, and I'm just going to call it evil.dtd. Okay, so we're going to save that there. We are then going to need to set up a web server to host the DTD file. So I'll just exit from the Python interpreter here, and I'm just going to say python 3 m http.server. We'll go and use port 8080. So it's going to host it because I saved the DTD file on my desktop. And now we're going to just create an XML query that will then input into the validator that will essentially reach out using XML external entity to our web server that we're running on the Kali Linux system that's hosting the evil.dtd file, and essentially tell it to use that DTD file. And yeah, so I'm just going to create that quick snippet now. It's going to be slightly different. All right, there we are, just set it up. You can see in this case now, doc type data entity DTD system goes essentially, will make a request to our web server that we set up with Python that's hosting evil.dtd. And then over here, DTD all, essentially, and you can see data is just the file contents. So in this particular case, again, if you're following along, make sure you replace this with your Kali Linux IP because it will be different. And now we can actually just input this. Now, before we actually do anything, before we run this in the validator, I want to explain a couple of things that I might have rushed through. All right, so first things first, this right over here, the first, the first payload, or this particular XML code will essentially load the contents of the evil.dtd file that we're hosting. And then, of course, this will be passed by the backend. Now, the evil.dtd file that we created essentially contains the entity that sends a request to localhost port 8888. This is executed on the target server, and as a result of that, if I just go to evil.dtd, you can see what it does is it essentially it embeds it in the C data section, because you can see that right over here. So C data. Now, what is C data? Even though this has been explained before, C data sections, can essentially be used to block escape literal text when placing, restricted or disallowed characters, with entity references. That's a security feature that we're sort of trying to avoid. You can learn more about, the C data sections. I can obviously, walk you through a little bit more. But, quite simply, C data sections can be used to block escape literal text when replacing prohibited characters, with entity references. when that is actually undesirable. So CData sections can appear inside element content and allow angular brackets and the ampersand character, for example, to appear. So that's why we're using it. Hopefully that makes sense. And as I mentioned when we explored XML attacks in the advanced injection attacks course, the prohibited characters are the angular brackets, so less than, greater than, ampersand, single quote, double quote. So what this does, right over here, or I should say what the evil.dtd file does, if I can just open it again, there we go, open it here, is what it does is it essentially ensures that the response contains restricted characters, and those characters will get embedded into the CData section, which is something we want. And as a result, the XML validator or parser will not raise any errors with the actual syntax or anything like that. So what we can go ahead and do now is just validate the XML here, and there you are. You can see XML is valid, and that's because of what we just did. We essentially embedded, you can see contents of evil.dtd right over here in the CData, section, and it's not going to be treated literally. So if we take a look at the response, we can see we have HTML here, which is interesting, and what appears to be a directory listing on the web server. So let's actually save this, and I'm just going to stop at the HTML tag right over here. Actually, hold on. That I can see flag 1, very interesting, and then another doc type here. Actually, hold on. We might want to start right over here. So doc type HTML. Let's see. We have directory listing and a flag. Interesting. Okay, so I'm just going to copy this here, and I'm going to save it as an HTML file so we can see what it looks like. So I'll just save it, and we're just going to call this listing.html. And now we're going to save that there, and we're going to try and open this up in Firefox. Let's see what we're able to find. So just open up listing, and there we are. We can see directory listing. Again, by leveraging the XXE vulnerability and again taking advantage of the SSRF functionality afforded to us therein, or as part of the larger XXE vulnerability or attack, we can actually read the files from the file system. In this case, we're just displaying the the actual directory here. Now, of course, I'll try and explain this a little bit more, but we didn't specify any particular directory because we weren't aware of that. So if I go back in here to our DTD file, you can see it just says the file system specified is just localhost port 8888. So it appears there's a web server that's hosting these folders of files. Obviously, this is the HTML response. So if we click on it, we won't get anything, but this is obviously a folder. And then we have flag 1. So how can we now leverage or utilize what we have just learned? And this is, now standard SSRF, if you will. How can we leverage this to access, let's say, the contents of flag 1? Well, we can obviously, or we should be able to do this by modifying the DTD file and specify the resource that we're looking for. So, if I go back in here and I say, instead of just localhost 8888, in terms of the actual system that we are trying to interact with, or, it's obviously localhost in this case, but we can just say flag 1 right over here, and let's save this now. And now if we go back, yeah, that should suffice. We can actually now just make, I'll just close this tab right over here. We just need to change this XML, and that's evil.dtd. Yeah, that should work just fine. So let's validate it. And there we are. We can see that because it's embedded in the CData section, we actually get the flag. So that's the value of flag 1. Now I'm not going to be going through the process of getting flag 2, or I will take you to the point where you can get it. But yeah, just wanted to show you how that works. Now, obviously, the most important file that we're looking for, or directory, is the SSH directory. So we can actually modify our DTD file, and instead of saying flag 1, we can just say SSH, because it's a directory. We'll close that there. And yeah, I don't think we need to modify anything there, but yeah, we can actually just run it because our web server is still going. Sorry, evil.dtd. Did we save that? Let me just make sure I've saved this. There we go. Let's try that again. There we go. And now authorized keys, we can see we have ID RSA. You can actually save this response, but we have ID RSA, private key and public key. Yeah, that's pretty much it. So how can we actually get the contents of these files? Because, you know, we can actually use them to SSH into the system. That's sort of the key here. So what we can do now is we have authorized keys, ID RSA and IDRSA.pub. So let's try and get the private SSH key, or keys if there's more than one. We'll do that by modifying our DTD file here, and we'll say SSH, and then in here we have ID RSA, right? And we'll save this in here. And now we don't need to modify our payload or XML here, so we just click on it, and there we go. So we have it, but we need to, you know, this is not formatted correctly, so we'll need to format this, but we can see begin RSA private key, and RSA private key, and I don't know if these are two separate ones. No, it just looks like it's duplicated, but you know, that's fine. So I'm just going to save this, and I'll show you how we can format it. So I just copied that there, and the problem with this is, you know, it's missing new lines. It's not formatted correctly. Now, while we can automate this, I'm just going to save this first. We're just going to call it ID RSA, just keep the names as they are. So ID RSA, so that's the private. Now we can actually utilize sed to automate the process for us of, you know, sort of formatting it correctly, or to restore it, if you will, I'm just going to go into my desktop here. And, you know, with sed, we can essentially say sed e, and we then say starts with, you know, begin private, begin RSA private key. So let me just take a look at this here. So what we're looking for is this. So begin, and then I'm just going to copy that exactly as it is. So there we are. And we're going to say new line, but we also have a few more that we need to provide here. And sorry, sed e, just a moment, is that formatted correctly? Yeah, we need to include a backslash here. New line, just enter, hold on a second. So sed es, yeah, that should be fine. And then private key, yeah, my bad, that should be, the ampersand is in here, and then n, and close this there, and this will be a new line, so backslash, my bad, and then we can say e, same thing, but now the end private key. So I'm just going to copy that now, right over here as it is. Copy that there. Okay, and we're now going to say, and we probably also want to specify what we're filtering for. And I'll explain what this does in a second once I have finalized it. So we'll say S, let's see. and I will say 64 in here. So 64, actually that's in curly braces. Limit that there. And actually, hold on, we probably want to specify that in there. Yeah, and then we'll just specify now on the final line the name of the file, which in our case we called ID RSA. There we are, formats it perfectly as you'd expect. And you can just compare it to the, actually, yeah, there we are. So we can actually ID RSA, and we can probably then save that there. So what did the sed command do? Well, first things first, you can see it adds a new line after begin RSA private key, or that string. It adds a new line before, the end RSA private key string. And then, of course, for all other string blocks, it adds a new line after every 64 characters. And we now want to save it. So, saving it should be as simple as just saying, we're just going to say, we'll just call it clean, or we can call it fixed, I think. Fixed ID RSA, something like this. There we are, that's formatted correctly. What we can do now is, so we've gotten the private SSH key, and we don't know who it belongs to. So in order to use an SSH key, if you've never used one before, we need to find the corresponding username or email for the key, right? We need to find a valid username regardless, but in this case, I saw that we had a public key. So the public key always contains, or typically contains, the email of the user or the account name, and then followed by the host name. So what we can do now is just modify the GTD file, DTD file, I should say. So we'll change IDRSA to, in this case, idrsa.pub. I believe it was what it was called here from the listening. No, that was the private key, but in the previous one we had seen it's probably .pub. I shouldn't expect it to be different. And then we can just run this again. And now, hold on. Now we didn't save the DTD file. Always forget to do that. So let's go ahead and run this now. So validate again. And now, yes, SSH, there we go. Do we have any? It should be at the end. So David at insecurecorp.com. And so we can probably infer that the username is David. Anyway, we need to yeah, we probably also want to save this. I'm wondering whether we need any formatting here. We don't need, we actually don't need the public key. So because we have the private. So in essence, what we can do is just say, let's see, we're going to say SSHI and specify the private key there. And we're going to say David, or try and use David. Yeah, we'll just say David at demo.ini.local. So the host name, and let's hit enter. And there we go. Password. What's the password? Wait, hold on a second. Fixed ID. Yeah, that should be fine. Unless we don't have any permissions set. So let's just set that right now. There we are. And we get access to the user David, and consequently remote code execution. So that's pretty much it. You can see it was quite an advanced demo that leverages more than one vulnerability. We started off, with by exploiting external entities, and then, explored server-side request forgery in terms of making a request to an external server resource that was essentially malicious. The DTD file was malicious in that it allowed for us to view specific data stored on the system, and as a result of that, we're able to access SSH keys, or the SSH key for a user account on the underlying server that we then leverage to gain access to the server. And that's pretty much it. That is remote command execution. And with that being said, that brings us to the end of the practical demonstration section of this video. All right, so that was how to identify and exploit an SSRF vulnerability in sort of a realistic context. And of course, in this particular demonstration, it was a bit more advanced in that it involved us chaining multiple vulnerabilities. Definitely go through the lab. Pretty much all the steps I went through are documented in the lab documentation. Test it out, go through it more than once. Try and play with a couple of things. Specifically, modifying the DTD file just to see what else you can do. But with that being said, that's going to be it for this video, and I'll be seeing you in the next video.